This is lesson number 50 in Algebra 1, Polynomial Equations, Ordered Pairs, and the Cartesian Coordinate System. Everything that you've already done, but just kind of a review to make sure that we fill in any gaps of things that you may have been missing. In lesson 48, we talked about the degree of a term. So if we have a term, 2x cubed, the degree of that term will always be the sum of the exponents. So this one, the degree is going to be 3. 2x squared y. There's an assumed 1 there, even though we don't put it there. So the degree of that would be the sum of the exponents, which would be 3. xy z to the 4th power, let's make that squared. Sum of the exponents. 2 plus 1 plus 4, the degree of that polynomial is going to be 7. Now when we string all these polynomials together, or not all these expressions together, or terms, we get something like, let's just make one up, like that. The degree of the polynomial is the degree of the highest degreed term. The degree of that is 3. The degree of that is 2. The degree of that is 4. Therefore, the degree of the entire thing is going to be the 4. Okay, because it's the highest. So if I have x to the 4th minus 2y squared plus 3xy cubed. This has a degree of 4, this one has 2, and this one has 4 because that's a 1 there. 1 plus 3 is our 4. So the degree of that is going to be the highest degree term, which in this case is 4. Alright? And one of the things, and again you've learned this in the past, is if we have an equal sign, that means we are trying to solve the polynomial. So in fact what we're doing is we're putting two expressions together, a 4 and an x plus 2, and we're putting an equal sign between them. And when we put an equal sign between them, we're trying to solve for the variable, in this case x. But what if we have y equals 2x plus 4? Alright, what we're trying to do is we're trying to make both of these sides of the equal sign equal, so that we can say that this equals this. So we have two variables. We usually look at the x and we say, okay, let's say that we put a 2 in for the x. So if we put a 2 in here, what will our y value be in order for those two expressions to be equal? Well, this is going to be 4 plus 4, so this side is going to be 8. So in order for this side to be equal to this side, y has to be equal to 8, right? So that we have 8 equals 2 times 2 plus 4. Is that a true expression? Yes, it is. So when x is 2, y must be 8. If I were to say, let's see if I can get rid of some of this. If I were to say that x is, well, let's make it 1. Then we have 2 times 1 plus 4. And what does that equal? It equals 7. So that means if x is 1, y is 7. If x is 0, we have 2 times 0 plus 4. So that disappears. 2 times 0 is 0. That means y is equal to 4. So we can just, there's an infinite number of values we can put in there. That if we replace x with a number, then y will be a number. So x is called the independent variable. Independent means it can be anything it stinking wants to be. Y is called the dependent variable, meaning that if x decides it is going to be a 2, then y has to be an 8. So it's dependent on what the x is. If the x wants to be a 1, like we have here, then y doesn't have an option. It has to be a 7. So it's dependent on what x is. So x is usually the independent variable, y is usually the dependent, because it depends on whatever x is. And when we have our answers like this, those are called ordered pairs. So we write them as an answer 2, 8. Because what this means is when x is 2, y is 8. when x is 1, y is 7. The first number is always the x value. The second value is always the y. Okay? And we do that so that we can eventually graph this on what is called a Cartesian plane. And I'm going to get rid of a bunch of stuff on here, and we'll start talking about a Cartesian plane, which you've already used many, many times. So let's go ahead and put that on here. And that is a Cartesian plane. It means we have a number line here and a number line here. Alright, and when I had a value, let's say I had a value of 2 and 8, so when x is 2, y is 8. And anything, here's our origin. Anything to the right of the origin is going in a positive direction. Anything going to the left is going in a negative direction. Anything going up is going in a positive direction. Anything going down is a negative direction. So if I were to graph this, the 2 is a positive, the 8 is a positive. What I would do, after I get rid of my little drawings here, is I always start at the origin, and since this is the x, I go over 2. Okay, that's what that represents, go over 2. And then that 8 means positive, means go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And that point right there is the point 2, 8. It's on a two-dimensional plane, meaning you have to have 2 dimensions, 2 and 8. Alright, now notice that each one, or this entire graph here, is divided into 4 pieces. There's 1, here's 1, and here's 1. And they're called quadrants. Quadrants. And there are Roman numeral 1, Roman numeral 2, Roman numeral 3, and Roman numeral 4. Your answer will always be in one of those 4 quadrants, depending on what number you're talking about, or which point you're talking about. So for example, the point we have right here is 2, 8. It's in the first quadrant. What if we wanted to graph negative 2, 8? Let's do this in blue. That means on this x-axis is our negative 2, so that means that we go to the left 2 and up 8 to where we're right there. So that is the point negative 2, 8. What if we were interested in, let's say, negative 4, 0? On the x-axis, we would go over 1, 2, 3, 4, and up or down 0. So that means the point is actually right there on that line. It isn't going to go up or down at all because it says up or down 0. If we were looking at 0, negative 3, what does that tell me? It tells me that my x value, we start here in the origin, doesn't go left or right. It doesn't go anywhere, but it does go down 3. And it ends up there. So 0, negative 3 is that point there. We went left or right, none. And we went up and down, we went negative 3. And we ended up there. Let's say we have 4, negative 2. That means on the x-axis we go over 4, down 2. Because the negative means down, or it means left. But when it's the y value, it means down. And it's that point right there. So that is 4, negative 2. Okay, so notice each one of them is in one of the quadrants there. Alright, that is pretty much it for lesson number 50.